The last simple object we're going to determine the field for right now is a sphere. But we're not actually going to determine the field for it. That's a little bit of a lie. This is actually derived in chapter 24 when we learn about Gauss's law, which is going to be a different technique for determining the field. Now, it's a helpful answer, and it's one that you might need in some problems. The first thing to understand is when we write something like this, little r is greater than or equal to big R is determining the sphere itself, right? So it's like I say, well, if I have my sphere, awesome sphere, that is going to be my big R. But then if I had my center and I'm at some point here, that we would call this distance little r. So we typically use little r as our coordinate, and we typically use big R as the size of our object. So if we are outside of the sphere, our electric field is 1 over 4 pi epsilon naught q over r squared in the r hat direction. This looks just like a point charge as long as you're outside of the sphere. So r in this case is not to the edge of the sphere, it's to the center. And so this is a really interesting result. Now again, we haven't actually done out the math to prove it. And doing this integration would actually be very, very challenging. So that's where we have a different technique that will help with it that we'll learn in the next chapter. But note that something different is needed if we're inside of the sphere. And one reason for that is once we're inside of the sphere, we have to ask, well, it was all of the charge on the outside of the sphere? Is the charge evenly distributed through the entire sphere? So this is true as long as you're outside of the sphere, but inside of the sphere we'll need the techniques from next chapter.